Okay, welcome everyone. We are in week 11. So today we are going to continue working on chapter 6, same as last week. And also next week, again, we are also continue working on chapter 6 until we finish it. So today we are going to talk about the function, those type of function that's very useful when you are dealing with the SAS coding. And then based on the function, we will learn about the group by and having by, how these two could be important for us, especially when we are using those kinds of uh, specific functions. So as I mentioned, every session we will first go through these specific slides. So far we know that whenever we want to write the SQL syntax, we always start with select statement. Then we'll go to see from which table, which attributes that we are going to select. So then we'll go through the uh, from statement. And then if we have some specific condition, for example, I don't know, if the type of the shoes are sandals or boots, then we use the when. And today we are focusing on group by and having by. Okay, how we can use these two, specifically these two, because one of them is really related to the type of function that we are going to use. Okay, so stay with me. By end of the session, you will learn how these two you need to use it and also when you need to use it. Okay, so the group by technically it's something similar, for example, to where, but the point is it's gonna categorize your output. Okay, for example, it's gonna give you some specific category based on the, for example, different type of quarter of the year that you're gonna sell something. You will see the example, and also the having. This one is very similar to the group by, but sorry, similar to the where, but the point is the time that you're using uh, having is again depends on the type of function and the when that you're using the group by. So when we go through the examples, it's gonna make more sense for you. Okay. So based on the function that we have the two couple of different functions. What our function does for us. So technically what they do. So for example, if this is a function, whatever function, you're inputting something X to it, and then something is going to happen here, and the outcome will Y. So that's the function. Okay. So different functions we have in SQL, we will see. Sometimes we will also have some function inside another function. So that one will be considered as a nested function. So the way that it operates, it starts from the inside and it goes to the outside. So the first one first do whatever needs to do, and the outcome of this one is gonna be applicable to the outer function, and the final outcome is gonna be based on the outer function. But in SQL, we have two type of functions. Okay, we have scalar functions, and also we have aggregate functions. This is the one that makes some differences when you're using it in the code. We will see. But what does it mean by scalar? What does it mean by aggregate function? Okay, so for example, uh, we have a table. We have a like a sale table. Okay, so first name, last name, blah blah, whatever. So row one, the data, the first record. Row two, row three, and so on. Okay, so whenever the function just involves in one row, one specific row, that one would be considered as a scalar function. Whenever multiple rows got involved into the function, That one will be as an aggregate function. But what does it mean again? Example, the first name, my name, Hossein, Mohit, I purchased $20. The second one, X, Y, Z, A, B, C, purchased $10. The third one, W, Y, Z, A, and D, purchased $20. Okay, so right now the first row is the first data, the second data, the third data. Each of them considers a record as data. Okay, imagine I want to see, for example, the number of characters for the first name in each row. Okay, so for example, right now I can just count it 1, 2, 3, 4, 5, 6, 7. So 7 is the Hussein number of characters. So the function for this one, we will see. The function for this one, we call it as a length, L-E-N. Okay, so if we, for example, if we say the length of the first name, technically it gives us for the first one 7, for the second one 3, for the third one 3. Technically, each time it just involved in each row independently to the others. It goes to the first line, counted, done, second line, counted, done, third line, counted, down. So that's the scalar function. It just involved one row at the moment. But the aggregate function, for example, I want to know 10, 20, 10, 20. So in total 50. I want to know the average price for all these three customers, the average amount that we sold them. So technically the function for it is AVG. AVG of the, for example, sale. So it's here is going to be 50 divided by 3. But the point is, for this function, we are involving 3 rows at the same time. Okay, so that would be considered as an aggregate function. So here again, in order to do the result for this one, we have to involve 3 rows at the same time. So the average of these 3 numbers at the same time is going to be outcome for us. This one considered as a count, as an aggregate function. Okay, or for example, I want to know the summation of these 3. So technically the summation is 50. So the function is sum for the sale item. So technically, again, for summation, I am doing calculation based on these 3 rows at the same time. So more than one record of data is involved. So technically, that would be considered as a aggregate function. But for this one, again, like the length, or like the other example, for example, the upper, it's going to change all the alphabets to the uppercase. So for example, if I apply the upper to the first name, so the first one is gonna be all capital letter of the Hussein and the rest. Okay, so technically it just involved one row by row. So it's not gonna consider all of them at the same time. So that's the difference between the scalar and also the aggregate function. So for example, some type of function, some other functions that we have, like a date function, also we have it. So far we already saw in some example. For example, the month of the date, day of the date, year of the date, and also this one is for the like a MySQL. Now parentheses, this one return the current date, the current time that we are right now at this moment. So for example, for today it's gonna be, I don't know, October 27, 2025. Okay, so let me run this one. Again, same as all the previous session. Make sure to have the advanced query here. So right now, what is gonna give us this code? You tell me. It's gonna give us all the column from the sale table. okay, where the month of the sale date is between October and December, right? Right? And the year of the sale date. But the point is we have a function for it here. So what's going to be the result of this function? It's going to be, I mean, this one is the date today, but technically we are going to calculate this one. Okay, so today is year 20, which year we are? 25. So technically this one is going to be 24. Okay, so right now in this case we are going to have those that sold in the October to the December of the 2024. The current data set on the MyEducator that we have, it's technically just on 2014, 15 something. So by running this one, so we are expecting to have no result, okay? But if I add 10 to this one, technically this one would be considered as a 2015. So if I run it, I will have exactly the reports based on the 2015. Or I don't know, if I change it, for example, to the 11, so the same, we are gonna have the report for 2014. So that's also this type of date function that we need to know. We already know it based on the uh, example that we had so far. But let me go through the again different type of scalar functions that we have. Okay, so the first one for the scalar, there are a lot of scalar functions. We are just going to review some of them. Majority of them already in the book. So if you want to go and check all of them, I will show you where they are exactly. We will review most of them here, but again, there are more than these. So make sure to check it on your side. I will show you where you can find. So I assume that most of you already work with Excel, right? So have you ever heard about the concatenate function in the Excel or concat function in Excel? So technically, by concat, you are, for example, having the first name, last name in the table, again, my name. For example, I would like to see this one, these two together as an output in the select statement, okay? So in that case, I have to use the concat function and mention first name, okay? I would like to have like a space between first name and last name. So quotation, quotation, there is a white space here and the last name, okay? So this one, technically the outcome is gonna give us just the full name together in the output. So that's a concat function. Again, it just goes through the rows by rows. So which means it is the scalar function. It's not involving multiple rows at the same time. Or for example, the second one, the round, we already had it in the assignments. So what does it for us, the round function? We had it in the assignments. It's gonna round it based on the number of decimal points or something. So for example, the XD, I don't know, for example, if the number is 28.5862, so technically if I mention to round it to the two numbers, it's gonna round it to 28.59, okay? So that would be a round function. Again, it's just involving row by row. It's not multiple rows. So which means this is the scalar function. Understand the difference. The length, return the length of the character string, the one that I showed you, for example, count, Hussein 7, ABC 3, whatever. Or the upper and the lowercase, again, return all the characters uppercase, lowercase. And for example, this one, replace XFT. So technically, you replace every occurrence of F with T in the original string X. You have some data. There's a description column. For example, one of the category, you want to change it in all the data sets. So you would say, okay, in the description column, replace all, for example, boots with sandals. So technically, it's going to replace all of them for you in the data. So if you go to the book, the 6.5, so chapter 6, 6.5. So if you scroll down, the date function as I showed you, and then different type of scalar function here. So for the scalar function again, for example, this one, the ABS function give us the absolute value of whatever number we have. That's the, again, it goes through the row by row. So do the math for based on the row by row. So it's going to give us the absolute value. So, or for example, SQRT again returns the square root of the number. Or again, round, we had it. Length, uppercase, lowercase. For example, LTRIM or LTRIMX, it's gonna remove all the leading spaces. For example, from the left. For example, this one, LTRIM space bill, it's gonna remove whatever space from the left side. Or for example, RTRIM is gonna remove whatever from the right side. Concat, as I mentioned, or for example, this one, substrings. So this substrings technically returns the n character from X beginning with the number of S. So example, substring of my White House, okay? So technically the 4, it's gonna start from the 4. So 1, 2, 3, 4. W is the fourth one, and then it's gonna count 5 character later. WHITE. So technically the outcome of this one is exactly gonna be the white word, okay? So make sure just go through these scalar function. Yes. Sorry. If you put the n 0, it's gonna start from the 0. So it depends on the sorry, S. So technically it says return the n characters from the X beginning with characters number of S. So my bad. I mean, if you put the, yes, the S0. So here we can see that again, my White House 4 is gonna count 4 characters and then it starts. So if you put the S to the 0, it's gonna count from the first one, and the outcome is gonna be my space W if we go with the 4. But if I change this one to 0 and this one to 2, it's just gonna give us my, okay, the number of characters after the one that we are exactly defining. It doesn't matter. So let me go through the rest. So we will go through some examples together. And same as always, again, make sure to have the advanced correlator on your side. And then after these 3, we will go through the aggregate function. Then when we need to use the group by and having by. So the first example. Display the sale date that occurred during 2014 using the year function in the where clause. So I'm not gonna run it, it's easy. So it's gonna give us telling us, give me the information of the sale. So the column is, the table is sale table. All the column asterisk where the exactly the year of the date is 2014. So this is the one that we already had it in some example before. So nothing crazy, right? So select all the columns from the sale table where the year of the sale date is 2014, right? Nothing special. Any question for this one? Good. Display our customer first name, last name, concatenated as a first name, last name, where the last name is displayed using all capital letters. So technically, it's telling us, okay, show me the concatenate version of the first name, last name, but I want to also have the last name as a capital letter. So technically, we have to use two functions inside each other. It's like a nested function. So what's gonna be the answer for this one? So we are selecting uncut first name space, like a space between the first name, last name, and then the last name. But for the last name, I want to have it as a uppercase. So for this one, I will use upper function inside of it. So technically, we can have the concats of the first name plus space upper the last name as a customer name. So technically, it's the first function, the one it's inside, start working, and the outcome of that one is gonna be the input for the outer function, which is the concat function. Okay, so let me have this one. So again, based on the concat function, the first name, the space between these two, first name and last name, and the last name I want it as a all capital. So it's gonna be Carol Abatelli. It's all of them are gonna be like a capital. So you do this one. Display the customer ID, sale date, and the number of years between the year part of the sale date and the year part of a today's date using the year and the now function. So technically, it's just asking us those couple of first attributes, the customer ID, sale date, and also the number of years. For example, if the sale happened in 2015, today is 2020, 2025. So we want to have the 10 as the number of years that passed. Okay. So how this one is going to be? So still we are dealing with the sale table. It doesn't matter about that one. So we are selecting which one, the customer ID, the sale date, and then it's telling us the number of years between the year part of the sale date and the year part of the today. So technically, the first one, what's going to be the first one? The now function give us today's date, right? So technically, the year of the now function is going to give us 2025 minus the year function. What is the attribute? Sale date, right? Sale date. So for example, this one as a, I don't know, as a number of years that passed. So if I go and run it, I have the customer ID, sale date, and sale ID. So year of the now function minus year of the sale date function, right? As a, for example, elapsed years. So right now we can see based on the today's date, 11 years passed, 11 years passed, and whatever we have until then. Okay. So the reason maybe at this point doesn't make sense. For example, what's the point of having number of years between today and the other day? That's you're right. It doesn't matter. But we want to just learn you can use function together in order to do some tasks. One of the things that we also have in SQL are custom functions. Custom functions, we are not going to work on it. It's more like an advanced level of the SQL. But based on the job that you are doing, maybe you need to create some function for yourself to, for example, calculate something out of your specific numbers in the data sets. Again, depends on the job you are doing. That would be the different. That's a custom function. At this point, at this course, we are gonna learn just built-in functions. The one that already created in SQL, we're gonna learn them, like a date function, like a scalar function, like a aggregate function that we are gonna learn. Okay, so that's the difference between these. Any question? Good, good. So the aggregate function, as I mentioned, in the aggregate function, it means they are involving multiple rows at the same time. First example is the sum function. It's going to give us the summation of the column. Whatever number of records in that table, it's going to give us the summation of the, for example, all the profit column in the sale date, for example. Or the average, the same, calculate the average for us. The count, for example, in some table, I want to count the number of transactions that happened in year 2014. So technically by counting all the rows, I'm gonna see how many transactions that happened. So that one also be another one. The maximum, minimum for sure would be the another one. For example, in a sale column, in a like a price column, I wanna see the maximum price of the item that we sold. So by sale by maximum function, you are again involving with the number of rows at the same time. So technically, for example, between the 20, 25, 30, it's going to give you the 30 as a maximum of that one. And also the same for the minimum function as well. So let's have some example. And after this example, you will see some difference between the aggregate function and scalar function, okay? So calculate the highest and the lowest price item from product table. Okay, but before calculating, let me so we have the product table and the price is list price. I want to have the maximum and minimum of the list price, right? So in this case, the answer for this one, let me run it through the SQL and ask you some question. So selecting the maximum of the list price, okay, we are naming it as the highest price, and minimum of the list price, we are naming it as a lowest price, right? Okay, so from the product table, how many rows and how many column this outcome will have? How many column, how many row? How many row? Two? Don't consider the first one, which is the like the header. So technically one. The maximum of multiple number is just one number. The minimum of multiple numbers is also one number, right? So if I run it, we'll have the highest price 10, so 180, lowest price 69. You mentioned two, you calculate it probably based on the header column as well. So the reason I'm asking this one because we are calculating based on the build based on the aggregate function. This one will matter later. We will see whenever we use some extra attribute here without built-in function, without aggregate function. Just wait a couple of seconds and you will see. So this one, calculate the number of product categories from the product table. Number of the product categories. Which function I should use for it? Count. I have to count the number of categories. Okay. So is just only the count itself is enough for this one? For example, we have, if it goes to the product table, there is a, I don't know, sandals category, there is a boots category, and also we have again sandals category and boots category. So technically for SQL, each of them, it's gonna count it once. So in that means what else we need to have in order to remove the duplication? This thing, okay? So for this one, we are selecting category column and we are counting it with the count function, but we are using the distinct. So technically use the distinct within the function as a category count. So if I run it, it's gonna give me just 8 distinct category, but if I remove it, it's gonna be maybe 1,000 something, 1,413. Okay, because those duplicated values still they are gonna count it as the number of category. So calculate the average shipping amount of all sales. So we have to deal with the sale table and shipping is here. Okay, so easy, right? Selecting, what's the function for it? Average of the shipping as whatever from the sale table, right? So in that case, it's gonna be average shipping of the as the average shipping amount from the sale. So how many column does it have? One. How many rows? Exclude the header. Yes, just one again. Because again, the average of multiple numbers is just one number, which is this. So technically, we are seeing here that there are a lot of decimal, okay, right? So the second, another example, it's gonna be how we can round this one as well, okay? So you tell me, what should I do in order to round it to 2 decimal points? So which means I should start typing round of this one, and then to how many? 2, right? So now we are seeing that how we can also again run the nested function inside each other, okay? As long as you know the logic. It doesn't matter how many functions. It doesn't matter which functions. The only thing that you need to know is the logic, how this one works, how you can, for example, put some function inside each other. You need to understand this rule. The result of the insider is going to be the input for the outsider one. Okay. Revise the query of number 3 to display the average shipping amounts for January of 2014 using the month and year function in the where clause. So technically the same one, just where the year of the, for example, sale date is 2014 and the month of the year sale date is the January. So which means the outcome nothing that much. Where is the my mouse? So we are just adding one extra rows where the sale date, which the month of the sale date is one, and also the year of the sale date is 2014. Okay. What would happen if I put or here? It's gonna show us whatever from the January of 2014, 13, whatever we have, or all the month in the 2015, 2014. So technically this one is just gonna give us again the value for that one, and we can also again round this one to 2 decimal points. See now, whenever we are going further, it makes more sense. The main reason of the SQL, we can ask questions. And this one, even just this simple question, the one that we saw, it is like exactly the real case. I, as a manager, I would like to see the outcome of the January of 2014. Maybe based on that one, I want to make some decision. Okay. So there should be some guy to give me the answer for based on that specific database. So we have to write the query for it. Okay. So now group by. Okay. The group by technically is there for us in order to like categorize the outcome. Okay. So by categorizing again, it means based on some specific condition, some specific features of your tables, whatever, it's gonna give us some specific results. So let's just go through this example. And you tell me what's gonna be the output for this one. Please tell me. Mm-hmm. Mm-hmm. So we are gonna have the average of the list price for each category, right? So technically, first of all, is this a scalar function or aggregate function? It's an aggregate function. In this case, we are using aggregate function with another attributes, which in this attributes, there is no aggregate function. You all agree? Just keep it in your mind, this one. We'll come back to this one. later. So technically, we are going to have for the sandals, for the boots, for whatever. Okay, we have the number. What's gonna happen to this code? Just thinking about it very deep. What's gonna happen to this code? Okay, so the first one we saw, it was the category column and also the average column. This one had 8 rows, and this one also had 8 numbers for it. Am I right? So each column, they both had the same. Okay, regardless of the second part of the code. If I put select category, it's gonna give me a lot of rows. Am I right? Right. So in table, we are gonna have in the outcome, it's gonna give me a table that has a lot of category. But still, the average list price is limited. Just those 8. So we are gonna have one table that one row, one column has a lot of rows. The other one has just 8, which is not related to the first column. So technically, it's gonna create some issue. It's gonna say that list contain non-aggregated column. This is incompatible with the SQL mode. Only full group by. So remember this sentence forever. Whenever you are using aggregate function with whatever attributes, technically you should use it alone. If you are using it with other column, with other attributes, you have to use group by for those attributes. Whatever number of extra attributes. If I had here, for example, product table, for example, if I had product name, if I had gender, okay? If I had product name also here, I also had to put it here as well as a second group by column. One more time. If you are using build aggregate function, it should be always alone. If it's not alone, it's okay. It comes with other attributes. For those extra attributes, you have to use the group by function. That's the rule, period. You need to know it. That's it. And I just told you about the logic why you need to have it. Okay? If I go through the example, it's gonna make more sense to you. Let me. So again, the group by clause defines the field on which the DBMS, database management system, will build the groups. So all fields in the select clause for an aggregate query must either contain either an aggregate function or appear in the group by clause. Here, the average list price is the aggregate one, but the category, it's the extra column. That's fine. For the category, you have to use the group by function. If you had product name as well, you have to say group by category and also product name, excuse me. Okay? So having by, it's very similar to the where, but when you have specific when you have a specific condition for that column that comes in the aggregate function. For that one, you have to use having one. For example, the average list price. I want to know those that average list price is, for example, above 20. In that case, I would say group by category, having by the average list price over than 20. Okay? I'm gonna go through the example. It's gonna make more sense to you. Just see this example. Select category. Okay? We are having the category column and summation of the quantity times sale price. Summation is the aggregate function, right? Okay? And we are calling it the total sale. Doesn't matter from which table to join to which table. At this point, it doesn't matter to us. Okay? Do we have aggregate function in this code, in this statement? Yes. Does it come alone or also other attributes are involved? Other attributes are here. So when you have the aggregate function, you should have it alone. If it's not alone, it's fine. You have to use the group by for those extra attributes. The extra attribute here is category. So group by category. Now it's telling us the summation of the total sale, I would like to have it as over 10,000. So in this case, we are not saying where the summation of this one is above 10,000. We have to use the having because we have extra condition based on the aggregate function. We will see in the example when you need to use, for example, where at the same time using the having. For example, in this example, if I wanted to see those that appeared in the October of the 2014. So in that case, I would say, okay, select whatever from product, whatever, where the date is October 2014, group by category, having summation over 10,000. So having it's only related to the aggregate function. If you want to have some specific condition based on the aggregate function result, you have to use having. Okay? So now we know when we need to use the group by, when we need to use the having by. So let me go through the example. The following example, I'm not going to run it. I'm just going to show it to you because I want to go through the assignment as well. Calculate the total sale amount, okay, for each sale. Total sale, which means the quantity times the sale price. Sort the query result by total sale amount in descending order. So we are selecting, at this point, it doesn't matter the from join. We are not working. We know already what's the from, what's the join. We know all of them. Now we are learning the aggregate functions. So we are having select we are having the select sale ID from the sale table and total sales amount is summation of the quantity times sale price, right? Do we have aggregate function? Yes. Aggregate function is sum. Do we have also another attributes? Yes. Sale ID. Sale ID, does it have any aggregate function? No. Which means for the sale ID, we have to use group by. Okay? And the same order by whatever. Calculate the total number of transactions. Total number of transactions, the function for it is count. That contain sneakers. Selecting count of the sale ID distinct. Do we have aggregate function? Aggregate function. Counts involving multiple rows. Do we have? Yes, we have. Do we have other attributes beside it? No, there is no group by. Okay. So from join product where category is sneakers. We are not saying, I don't know, group by category having a sneakers. No, because again, there is no extra attributes plus the aggregate function. Does it make sense, guys? What I'm saying when we have to use the group by? Yes. Display the number of products in each category as well as the average list price of those products. So selecting category, counting product ID as a number of products, average of the list price as an average list price. Do we have aggregate function? Yes. How many? 2. Does it matter? No. Do we have extra attributes beside those? So what is category? Yes. So category, which means the extra attribute, and it doesn't have the aggregate function. So which means we have to use a group by for that one. Modify the query, for example, A to display only those products whose color is black. So for this one, do we need to use where or do we need to use having? Modify the query, for example, 8 to display only those products whose color is black. We mentioned that if the condition is related to the aggregate function, we have to use as a having. Color is related to the product ID? No. Color is related to the list price? No. So which means before the group by, we have to have where statement. Select category, whatever, from product, where color black, group by category. Okay. But if I would say I want also those that the average list price is over 20. In that case, I have to say having the average list price over 20. Right? Because again, it is related to that one. For example, like here, the summation of the quantity blah blah over 10,000. Okay. So let me go through the assignment in section 6.5. Make sure to go through this specific chapter on your home. So 6.4 group by. What are the dollar amounts of each sale? Dollar amount of each sale again, which means sale price times quantity. Okay. For each customer, include customer ID, sale ID, but only include sale larger than 600. So name the column total amount, use the round function to blah blah. So for this one, we have to use the aggregate function. The aggregate function for this one is the sum. Okay. And also we want to have the round as well. So technically rounds of the summation of the sale price quantity times 2, I mean by 2 decimal point as a total amount. This one makes sense? Okay. Do we have aggregate function? Yes. At the same time, we want to have customer ID and the sale ID as well, right? So which means extra columns, extra attributes with no aggregate function, which means I have to have group by for both of them. Group by customer ID and sale ID. I don't want to talk about the from, sale, join, sale item. We know already these two. Okay. So group by customer ID, which comes here already, and sale ID, which comes here as well. We have to mention it's from the sale table. but it says only includes sales larger than 600, which means it's related to the aggregate function, which means I have to use the having some sale price quantity over 600. Make sense? Cool. Number 2, what are the dollar amounts of each sale? Again the same, but this time made on January 1, 2015 for each customer, include blah, blah, blah. Function is the same, right? Is this aggregate function? Yes. Why? Because multiple rows are involved. Do we have other column beside these? Yes. Sale ID, customer ID, which means we have to have group by. Group by customer ID, sale ID. There is extra condition for it. The condition is you want to have just the January of 2015. Is January 2015 related to this specific aggregate function? No. So we are not going to use it as a having. We are going to use it as a where. And where we are using where? Before group. Okay? We are not going to put it, say, group by, then where. Okay? So technically that's the amount. And the last one, for each category and color, what is the maximum list price of the men's shoes in the category and the color? Maximum is the aggregate function. Maximum of the list price as a maximum price, category, and also the color. From product table, group by, yes, category and the color, we have to have the group by. But the point is, the condition is for men. Is men related to the list price? No, which means we have to use it as a where and order it by category as well. Cool? Easy. So what we learned today? We learned about the functions. There were some custom functions that we are not going to learn. It's different. It's more the advanced level, and again, depends on the case that you are going to work. We are working on the built-in functions. The built-in functions for this one, it's going to be those scalar functions, those date functions, and also aggregate functions. Scalar functions, we have to deal with just row by row, like a length, like a upper, lower, SQRT, whatever we will learn, and you can also check it in the book. The aggregate function, which means they are dealing with multiple rows at the same time, like an average function, like a count function, like a maximum function, minimum function. So there is a rule. If you are using aggregate function, it should be always alone. If it's not alone, it's fine. For whatever extra attributes, we have to use the group by for each of them. If we have 5 different attributes plus that aggregate function, you have to have the group by for those 5. Then having, if the condition, the extra condition is related to the aggregate function, like the, for example, we are calculating the summation of the total sale, and we would say the total sale should be over than 6,000. So for that one, we use have having. But the condition is not related, you can use it as a normal where. The order matters. Select from, where, group by, having, order by. Okay, cool. See you Wednesday. Any question? Sorry? Yeah, absolutely. Email me or set up a time we can meet. Yeah. Okay, welcome everyone. We are in week 11, section 2. So today again, we are continue working on chapter 6. So what we are gonna learn today is subqueries. Okay. So that's a part that I really like about it. So before going further, again, the same slide that every times we are just seeing. Let me move this one. Okay, so as we definitely by this moment we all know about all the orders. for the SQL. Let's review it one more time. So in the SQL, again, we always start with the select statement, which we need to know which attributes we're going to select, then go through the from statement, which we need to say, okay, from this table, or whatever we need to have. Sometimes this view, this specific view, which we're going to talk at the end of chapter 6. And then the where that we are going to see which specific condition we would like to add. And then we learned something last session about the different type of function, the aggregate function, and also at the same time, we learned about the scalar function. So we mentioned that whenever you have the aggregate function, you should have it alone. But if you don't have it alone and it comes with other attributes, in that case, you definitely need to have the group by in order to support those extra attributes. And then if you have some specific condition that applies to your aggregate functions, then you need to go through the having. Otherwise, you always need to use where before the group by, and the order by is the same. So by subqueries, technically nothing new. There is nothing new to learn about the subqueries. The only thing that difference is when you need to use it and where you need to use it. Okay. And sometimes, hey, and sometimes for the subqueries, the equivalent code is also exists. You can do it with the join function. Okay. Again, depends on the need. In our case, depends on the question that you are going to go through the exam or assignment. They might tell you that you need to use the subqueries, or you technically you will understand that there is no way to use it just for subquery. There is no other option. Okay. So we will see it through the examples. Okay. But the place in the syntax that we can use subqueries, we can use it with these uh, 4 different places. Select, within the select statement, within the from statement, within the where statement, and within the having statement. Okay. So technically by subquery again, which means one query nested inside another queries. Okay. So for example, you start something with select whatever from whatever, and then for example, you can have something where, and that's the place that you can insert a subqueries. How? By opening a parenthesis and writing another query. For sure, for the another query, what are the at least statement that we need to have? Which statement we should at least have in order to write a query? Select and from. So you definitely have to have select from. And then if you need to have extra things, you can have it. So technically what subquery does for us, subquery technically creates some food for the outer query. You are creating something by this insider query. So the result of this one, the output of this one is going to be the input for the outer query. So you will see in the example. So when I go through the example, it's going to make more sense for you. What does it mean by subquery? Okay. So as I mentioned again, just make sure to always this one start with the parentheses. So we will start with the where clause. Okay. That's we are gonna have it. But before going through the where clause, we have 2 different type of subqueries: dependent, independent, correlated, uncorrelated. In one sentence, if you can run this inside query alone, then you are going to have the independent queries. If you cannot run this one alone, which after running it, you're going to receive some error, then that's a dependent version. That's a correlated version. What does it mean you cannot run it alone? Probably there are some attributes, some table in the insider query that you need to address it from the outer queries. That's why you cannot run it alone. But at this point, before seeing example, just learn these 2. We have 2 type of subqueries: correlated, uncorrelated, dependent, independent. If you can run it alone, that would be independent or uncorrelated. If you cannot run it alone, that would be a dependent or correlated. Okay. Again, when we go through the example, same as always, it's gonna make more sense for you. So, the first example, use a subquery to list all products made by manufacturer Nike. Okay, same as always, make sure to open this one. But at this point, don't care about the subquery. Just write it based on what you already learned. So right now, it says that, again, forget the subquery, list all products made by manufacturer Nike. So if I go through the table, all product by manufacturer, we have to connect product table to the manufacturer table, right? So list all products, select whatever attribute you want to have from product table, joining manufacturer table through the manufacturer ID, okay? Where the manufacturer name is Nike. Okay, so that's the normal one that we already know, right? So this is the normal one that we already learned. Am I right? Select from the product table all the attributes from product table, join manufacturer table, and through the manufacturer ID, where the manufacturer name is Nike, right? So if you run it, we are gonna have all the reports from the Nike, okay? So how do you think we can use like a subquery in this one? In the where statement. For example, if I have this one, this, if I would say select all products from product table, okay, where manufacturer name is Nike. Can we run this code? No, because manufacturer name is not in the product table, right? But what if I can do something that the outcome of that query would be Nike? Which means if we can write something here, if we can write something here, okay, that the outcome of this one would be Nike, then we will have the result for this table. What do you think? Let's go to the table again. So right now, we have the product table. We have like a manufacturer ID here. Here we have manufacturer ID. Here we have manufacturer name. Okay. So let's, for example, assume that we are gonna have manufacturer ID here as a Nike. Okay. So right now, if I have manufacturer ID with Nike, is not possible because this is ID that's a text. So this is different. But we can create something that kinds of correlate these two. So in order to have Nike here as an outcome, I might go through the manufacturer table and says, hey, select manufacturer name from manufacturer table, okay, where the manufacturer name is Nike. So technically, I can have manufacturer ID from that specific query and put it here. So do you all agree if I write here select, okay, manufacturer ID from manufacturer table where the manufacturer name is Nike, do you all agree the outcome of this query, it's gonna be a manufacturer ID which is related to the Nike? Yes? Do you all agree? This is the different query. Forget the previous query. This query is selecting manufacturer ID from manufacturer table where the manufacturer name is Nike. So the outcome is gonna be those IDs that's related to the Nike, right? Right? So in that case, for example, the outcome of this one, for example, would be 2. The ID 2 is for Nike. Then if I put ID 2 here, the outcome of this result is gonna be exactly the Nike product. Because in this table, these two tables are related together through the manufacturer ID, right? We found that manufacturer ID 2 is related to the Nike. So in that case, if I say, okay, from product table, where manufacturer ID is 2. So technically 2 is related to the Nike. So it's gonna give me the same result. So in that case, this is gonna be the one that we are gonna have. So I'm just making this indent in order to just make it more understandable. So here we are selecting from product table where manufacturer ID is something. This something should be related to the Nike. Okay. Now in this subquery, I would say select manufacturer ID from manufacturer table where manufacturer name is Nike. Okay, we will run it separately. First of all, do you think are these two queries are related or not related? Are they dependent or independent? Dependent, independent, which one? Can I run this one alone? Yes. So it's gonna be independent. Let's just run this one alone. I hate and I don't have mouse. So if I run this one alone, the outcome is gonna be manufacturer ID 630. So 630, do you all agree is related to the Nike? Yes. Yes. All agree. So again, if I go back to the Discord, so the outcome of this specific query is 630. If I just remove this one and put 630, I will receive those products that manufacturer ID is 630. Manufacturer ID 630 is Nike. So if I run it, I will have this table. Just remember this table. Now, if I just run the previous one, it's gonna be exactly the same result. So technically, that's how the subquery works. You can create some query inside another query. The insider one, it's gonna create some food for the outside, for the outsider one. So in this case, this is the way that these two works. These are independent, which means you can run them individually and they're not going to impacting each other. Okay, so you might say why I don't use the join. Again, at the end of the day, in a normal world, in a free world, it's your will. If you would like to go to join, if you after a couple of probably month, yeah, if you're in this business, if you're in the like a database management business, it's your choice. You can do whatever you want. But we will see some example that there is no way to run it unless you need to know how to run the subqueries. Okay, so the second example. Use the subquery to list of the products made by manufacturers in Washington states. So technically, this is exactly similar to that one. You have product, you have manufacturer table. By join function, you can say, okay, select whatever product that I want to have from the product table, joining the manufacturer table through the manufacturer ID when the state is Washington. Okay. So technically, for this one, I can exactly do the same. Find the manufacturer ID for those that created in Washington. Okay, but there is a one kind of difference. In the previous one, we were lucky that we had, for example, just 630 as Nike. Do you remember we said that, for example, in some example, where the state is California, where the state is either North Carolina, where the state is Georgia. So technically, in those cases, if you remember, we had something like in parentheses in Georgia, in California, in whatever. Okay. So if the outcome of the query inside query would be more than one number, I would have a problem because I said equal to 630. But if I had, for example, 630 and 480 equal doesn't work. So in that case, I had to say in. So if I right now go back to this code, and if I just change this one to in, it still is gonna work because it says in parentheses, we just have 630. That's fine. But in this example, in the second example, we want to see those manufacturers in Washington state. So there is a possibility that more than one manufacturer are in the Washington state. So definitely for this subquery, we should use in. Okay. So how this one works, let me have the code. So in the normal one, we would say, okay, select product from product table manufacturer and connect it through the manufacturer ID between the product and manufacturer table where state is Washington, right? Is there anyone in this class that right now doesn't know what this code do for us? For sure, no, you all know it. So in that case, I would say, okay, same as previous one, select asterisk, select all column from product table where manufacturer ID is something. What is that something? It means those manufacturer that are already created in Washington states. So in that case, I would say, okay, select manufacturer ID from manufacturer table, like the one we had. In the previous one, we said that where manufacturer name is Nike. Here we are gonna write where state is Washington. Are these dependent or are these independent? Independent. We can just run them individually. So if I want to run it individually, I don't know if I reach run it or not. So you see, manufacturer ID right now is two number, 655 and 855 and 886. So if I have equal, it's not gonna work because equal cannot be equal to two numbers. So in that case, we should have the in this two. So right now, if I run this one, it's gonna be this, but if I know the answer before running this one, if I know 855 and then 886, so I will receive the same outcome. You see, the reason I'm just, yes. If I use equal, do you think, okay, can we say equal A is equal to 855 and 886? So that's what. But I can say A is in 855 and whatever. Okay. So that's why it's always safe to go with in. Yes.
How did we join the?
In this case, we are not doing anything joining. So technically, I am getting the outcome from manufacturer table. The outcome in manufacturer table, it came out these two numbers. Okay. So technically, again, one more time, the outcome of this query is giving us the numbers, the manufacturer IDs that right now they are created in Washington State. In our example, it's just two. Okay. So if I go to the product table and if I would say, give me the product that the manufacturer ID, these two, it is exactly similar to what we are doing with the join function. Okay. But again, at this point, you might say, why should I go with subquery? Join works for me. Again, at the end of the day, it's your call. But sometimes you will see you don't have any choice. You should go with the subquery. Okay, we are just learning the basics of subquery right now. What does it mean by subquery in general? Okay, just at this point, I just want you to understand the logic of the subquery. That when you are using one query inside another query, the one inside is creating some outcome, and the outcome is gonna be, bless you, is gonna be the input for the main queries. Okay, so the use a subquery to list our product whose list price is larger than average of the list price for all products. So just think about it. And again, forget the subquery. How you can address this one? Tell me. Tell me. So forget the subquery. List all products. So we are selecting asterisks from which table? Product table. So if I go through the product table, I have list price here, right? So where list price, the list price larger than average list price. So larger than, what's gonna be the next? AVG list price. Okay. So is this right? How? Why no?
Like we didn't,
What is that what?
we didn't, we didn't take that from
Would you then take which part from product table?
average.
The list price is in the product test. For sure we need the subquery, but why? Can we run this code? The main issue with this code, we cannot use aggregate function into the where statement. Okay, this is the aggregate function. You cannot use the aggregate function in the where statement. Okay, but right now you can open a parenthesis and say select, okay, AVG list price as the average from the product table. Okay, so you see, so let me show you how it's gonna be. It's gonna be select average list price from the product table. Okay, so if I run it, I will have those that the list price is over than average list price. The point is, if I had the average list price value, for example, $26.85, I could just easily put it here. First of all, is this the dependent or independent? Is this dependent or independent? Independent, you can just easily run this one. So if I run this one alone, so average list price is a aggregate function. Is it alone? Yes, so we don't need to have any group by. So if I run it, the value is 48.59. 48.59. 48.59. So in that case, I could put 48.59 here, and the outcome would be the same. Okay, but with that specific subquery, that's the way that you can create. So this is the one example that if you have to run it, you definitely have to write the subquery. You cannot run it without it. Okay, so that's the way that you can use the subquery. So let's just go a little fast. So now all of these that we already saw are the independent, uncorrelated. But let's see this example. List the employees who hired before their supervisor. Employee supervisor, we know that we should have that recursive relationship, employee table, manager table, supervisor table, all things. So technically, they're gonna list selecting the, for example, last name, first name of whatever employee from employee table, where the hire date of these people, okay, is technically before the supervisor. Okay, so in a just simple English, I should have this one, selecting employee first name, last name, whatever, from employee table where the hire date, okay, is before their supervisor hire date. So technically, I have to have here the supervisor hire date. So I have to write some queries that gives me the supervisor higher rate, higher date of those people. Okay. Okay. So we should definitely have to use the subquery. Let me go directly through the code. And you tell me, what do you understand from this code? The first part, selecting last name of the employee from employee table, right? Where the higher date is less than the higher date of their supervisor. But for this one, we are typing selecting higher date from employee table. Okay, from employee table, which we are this time we are making the supervisor because we want to name the have the name of those supervisor, the higher date of supervisor. Where reverse supervisor from employee ID from the supervisor table, manager ID from the employee table. That reverse rule that we had in the last 2 weeks. Whenever you are trying to connect these two tables, you have to use the reverse version. Okay. So right now, this query giving us some higher dates of the supervisor, and then it's gonna calculate if it's later than the higher date of the normal employee, it's gonna give us in the output. Otherwise, it's not gonna give us. So this specific query, is it dependent or independent? It is dependent, but why it is dependent? It is dependent on the class deploy, but through what? Exactly. This manager ID, it comes from the employee table, which in this table, we don't have employee table, we have supervisor table. So technically this manager ID comes from this one. So if I run this one, we can just do it. If I run this one, it's not gonna work. It would say that there is no reference for this table. Okay. Yeah, because it's outside of it. If I just run this one alone, it would say, okay, where is this E? There is no E, but we have it here. That's why these queries, we call it as a correlated or dependent. Yeah. So if I just run it, there are only two employees, Sisk and Browner, that they hired before their supervisor. Cool? Make sense? So now let's see when we can have the subqueries in select statements. So what we are doing in select statement, we are selecting the type of column that we are gonna see in the output, in the outcome, the attribute in the outcome. So when we are using in the select statement, do you all agree when we are creating a subquery, technically we are creating some table, right? Which that table, first of all, they are temporary, they are not permanent. For example, the product table right now is permanent in our database. But for example, when I'm creating some table based on the category and average price, category 1, category 2, category 3, 20, 30, 40, whatever. I'm creating a table with 2 columns and 3 rows. Do you all agree? This is a temporary table, it's not a permanent table. We are just creating it to just see as an outcome. So technically, whatever outcome of that specific queries could be just one column, could be multiple column. They are gonna be the new columns based on the whole select statement from the first query. But the point is, let's see how we can do it. Again, this one can be dependent, can be independent. The first example, list all products. Okay. How we can list all products? Select asterisk from product table. In the same query, display the average list price for all products as well. We are saying that, okay, select all products from product table. Okay, what we are saying that average list price of the all products, which means ABG of list price. Okay, list price, average of the list price. Is this aggregate function? Yes. Is it alone? So what is this thing? It's not alone. Okay. So we have asterisk, which means all the columns. So whenever we have extra attribute, we should have group by. So I should have group by for all columns. This is crazy. I don't want to do that. All I can easily do is to just go and do this. Select asterisk. Instead of that one, I would say select average list price from product table, name it as the average price and product table. So technically, I am going to have all the product name, product items, and also the average price. But the point is, for the sandals, 48.59. Sandals, 48.59. For the boots, something like that. So for all of them, we have the average list price for the whole category, whole the items. Okay. So technically, again, based on the question, average list price of all products. We didn't say, for example, a specific category, all products. It's gonna do the summation for all products divided by the number of products. So that's the way that we can use queries in the select statements. Okay. So the second example, number 6. List all customers and number of transactions for each customer. List all customers for sure. Select customers from customer table. And the number of transactions for each customer. I want to see, Hossein Mohit, how many items this specific person purchased. How many items this specific person purchased. So this one, that would be a little different, but let me show it to you, then it's gonna make more sense for you. We are selecting all the column from the customer table, right? But at the same time, we are creating some extra queries. The queries, first of all, it's selecting, counting all of the sale ID, okay, from the sale table, where the customer ID from the customer table is equal to the customer ID from the sale table. First of all, is this the dependent or independent? Dependent, because we have the customer table here, which we are not addressing it here, we are addressing it here. Okay, so technically here we are saying, okay, go there whenever the customer ID in the sale table is equal to the customer ID in the customer table, which means this person purchased. Otherwise, it wouldn't be available in the sale table. Do you all agree? If Hossein Mohit in the customer ID 1 has not purchased anything, I wouldn't be in the sale table. If I'm in the sale table, customer ID 1, which means when there is a match, which means this person purchased items. Whatever number that this one appeared, it's gonna count. If this match appeared twice, it's gonna put for Hossein Mohit 2 times purchased. That's why we have the counts of the sale ID. Okay? Exactly, it goes, for example, it goes to the sale ID 1, the person Hossein Mohit, customer ID is 1. Against sale ID 100, again, Hossein Mohit customer ID 1. So it's gonna count these two. Okay? And it's gonna put the 2 under, I mean, in front of the Hossein Mohit name. And name it as a number of sales. So in the column right now, in the outcome, we are gonna have all attributes from the customer table plus number of sales. So which means we are gonna have, for example, this person 1 time, 3 times. This person with this specific customer ID purchased 3 times into the sale table. Okay? Make sense? Sure. No, you ask me. So one more time. Let me go this way. We have customer table. Agree? Customer ID, first name, last name, whatever. We have sale table. Sale ID, customer ID, whatever. Agree? Customer ID 1, Hossein Mohit. Customer ID 2, what's your initial? AD. D. Customer ID 3, X1. Sale ID 1, who purchased it? Hossein Mohit. Sale ID 2, who purchased it? XY. Sale ID 3, who purchased it? Hossein Mohit. Sale ID 4, who purchased it? AD. 2. Okay? So, do you agree? Whenever I find a match here, I can say, okay, that specific customer purchased something. For the first one, is there a match for this one? Yes. So technically customer ID 1, 2, 3. So right now 1 is for customer ID 1. The second one, related to customer ID 3, right? There's a match for it, yes. Sorry, 3. Customer ID 1 again purchased it. So 1 more for customer ID 1. Customer ID 2 purchased the first time, right? So just go to the end. At the end of the day, it's gonna count for customer ID 1 2 times, for you 1 time, for the customer ID 3, which is the XY, just 1 time. Okay? That's how this matching works. So technically, here in this specific one, it's gonna create some matches for this outer query. But just by watching what I'm doing and just listening, you're not gonna learn. You have to go home. There are again multiple assignments for chapter 6. Just for this specific chapter, you had over 10 assignments. You need to go there, just do whatever you can to learn it. But this is the whole idea. So, where we are. Now, where we can use it as in a from clause. So whenever we say from, what does it mean? We are selecting some table from this table, joining to this table, whatever. So those table, they are permanent table. Do you all agree? Yeah, from product to customer table, they are already available in that set. Sometimes we need to create some temporary table to have the better result. Those temporary table, for sure, they need to be created by a query. A query that this time we are just putting it into the from join that area. This example, list all customers in the same query, list number of sales for each customer using subquery in from clause of the outer query. Let's just go directly to the answer, because I would like to also go through the assignment as well. So, let me make it more readable. So, what's saying us list of all customers in the same query, list number of sales counting, number of sales for each customer, okay, using a subquery in the from clause. So select first name, last name. I want to have something as a number of transaction, okay. Do we have any number of transaction columns in the whole data sets? No, which means we have to create some table that this table have a column that the column name is number of transaction. And we need to pay attention. If you are creating some extra table, that table should have a key that would be matched with the original table, like a primary key, foreign key. Other than that, you cannot join these two tables together. Okay, so from customer table, in the customer table, we have customer ID, right? Now, I would say join some table, which that table should have one primary key, which is in common with the customer table, and also have some extra column that could give us the number of transaction. Okay, so easy. I am selecting customer ID, right? And counting the sale ID. By counting the sale ID, I can say the number of transaction, right? If I am counting the sale ID, it's gonna give me how many transactions that happened in that table. From the sale table, the point is, do we have aggregate function? Yes. Do we have extra column? Yes. We have to use group by customer ID. So technically the outcome of this table, it's gonna be something like this. The customer ID, okay, and also the number of transaction, the customer ID 1, for example, 5 times, customer ID 2, 6 times, and so on. The fact that's give us the related number because we are using the group by. Okay, otherwise it doesn't work. We know that. So we are naming this table some query, whatever. I'm just naming it some query. So simple. Right now, I am selecting first name, last name, number of transaction from customer table, joining some table. The table I just created and name it as some query on customer ID from customer table customer ID from some query table. This some query, this is the one that we created. The common key is customer ID key. So if I run it, you will see the first and last name and number of transactions for each person. Digest a little. Is this dependent or independent? Huh? Independent, because there is no specific. So we can technically, by running that query, we would have that table, the customer ID table plus number of transaction, right? Right now, with that column key, common column, which is the customer ID, we are matching the first name from first and last name from this table to the number of transaction from this table. Make sense? If it doesn't make sense, let me know. Don't be shy. Yes. Sum query is the table name. We name this table as a sum query. We can name it XYZ. It doesn't matter. The only thing that matters, whatever name you are using, in the last line, you have to use that specific name.
So, like, we call it substitute name for customer.
Here, we use this one, sum query, as a table name.
Yeah.
The dot, customer ID from customer table, that's the original table. Customer ID from sum query table. So technically, this one, just forget about the subquery. This is exactly a normal join function. Imagine you had this sum query table. So you would say from customer table, joining sum query table, on customer ID from customer table, customer ID from sum query table. The fact is we don't have this sum query table. We are creating it by subquery. Nice. This is just the beginning. You have to go and practice. Yes. That's the part that we said we can use it in the from statement. So right now, this would consider in the from statement. From, join, they are the same. You cannot put it in the from. So if you put it in the from, then you are going to join what? So what you are telling that? Technically, in the from statement, we just can have one table. You cannot say customer from customer and some query. Agree? Mm-hmm. But the things that now you are saying, let me try this one. This one should also work. Is this the same outcome? James Dominic number 2. Should be the same because again, from A to B, B to A doesn't matter. Yeah, so that's the case. It would say, for example, from A to join A joining B table or from B joining A table. So that would be the same. But yeah, you're right. We can also use this one technically here. Right? And that's the way you can learn. Exactly. Thank you. So by just replacing these two, sweeping these two, so you can see both of them. Again, we all also know from A to B or from B to A, doesn't matter. Okay, good. Nice, cool. So very quick. Uh, 6.6, the subquery section. Make sure to go through all of these again. They're all what I discussed. Just different example. And then we have assignment 6.3 and 6.5. So the 6.3 is for aggregate, the one that we talked about it Monday, and also plus subquery at the same time. So the first example, how many products does Red Cat have from manufacturer 154? Okay, name the column, number of products. So selecting by counting all the columns as a number of products, number of products from product table where manufacturer ID is 154. We are using scalar function, or are we using the aggregate function? Why it is aggregate? Because it involves multiple rows of data. So technically, we are just gonna have 12 number of products. Or the second one, this one. List the name and list price of the product name, list price, that were sold on a sale for which the shipping cost was over 60. Use two level of subqueries. Technically, you have to write 3 queries. So I will start from the end. In this one, I would say, give me the sale ID from the sale table where the shipping is over 60. So the outcome of this one is gonna be sale ID, that the sale ID, the shipping is over 60. Then it goes to the second query. The second query, based on this sale ID, it's gonna give us the product ID. So that product ID would be exactly related to those product name and the related list price that the shipping is over 60. If we were supposed to do this one in the join, we had to write the join function 2 times, connect three different tables. We had to connect a product table, exactly sale item, sale table to product table. Okay. And this one, again, the employee name. Employee, again, I'm gonna record all of this for you. You can just watch it later. Just at this point, pay attention to it. List employee first name, last name, hire dates of employee who were hired before their managers. Exactly the example that we had. So the same thing that we had. And then if you scroll down, oh, it just, oh, there is a possibility that some glitch is happening because of the Google Chrome or whatever the software. I was going to the second one, but it goes to the assignment 6.5. So in this case, always go to your student menu, go to your assessments, okay? If you have some issue whenever you are running this assignment embedded in the book, go here, and then from here, open it. So right now we were talking about assignment 6.3 and assignment 6.5. Now it's better. So this is the first one we talked. So this one, give a list of customers, IDs and name whose purchase during month of January 2014 were always the same color. Okay, same color. We have to count the number of colors. For sure, we need to use the distinct. If the distinct version is equal to 1, if Hossein purchased 10 items, that all 10 items are red, it would count all of them as a 1 color. If Hossein purchased 2 items, that one of them is red, one of them is blue, it would count it as a 2 color. In that case, it's not gonna fit in this equation because it says that they should be in the same color. Okay? Where the outcome of this one should be equal to 1. Okay? The outcome of this one should be equal to 1. One more time. Hossein is a customer. Purchase 5 items. All of 5 are red. So if I use the distinct, I can say Hossein purchased all of them in 1 color. So the outcome of this one is going to be 1. So it's not be in the outcome. But if I purchase 1 black, 1 blue, 1 red, I'm not purchasing all in the same color. The outcome of that one is going to be 3. 1 is not equal to 3, so it's not going to be in the outcome. But what is this one? It says selecting count number of colors. By number of colors, which means I have to use a distinct. Because again, if I don't use a distinct, still 5 reds is going to be 5 different color for the SQL. SQL doesn't know red is all the same red. I have to use a distinct to remove the duplication. So from product table, join sale item table, normal analysis, where customer ID, blah, blah, and month is January, year 2014. The outcome of these is gonna be some number. Okay, let me just run this one. Mm. Oh, yeah. Uh, I can. Oh, yep, probably. No, unknown column, customer ID. Oh yeah, because yeah, they are not. I just did it. They are not related. They are not the independent because again, customer ID is here, so you cannot. Okay. So in this case, it's gonna give us some outcome. These people they purchased only in 1 column, and this is the 2. The 3 is almost the same. Just again, sum of the quantity. Check it if you want in the video later. I'm just gonna go to the second one. 6.5. List name of the manufacturer of the black sneakers that cost over $70. Use a subquery in the where clause. Note categories are lowercase in the database. Colors are capitalized. So selecting distinct manufacturer name. You want to have just manufacturer name. List the name of manufacturer. From manufacturer table. Technically, we had to join to the product table and check the black sneakers and ID, blah, blah, everything. Now we are saying that where manufacturer ID is something. That something is those that over $7 category are sneakers, color is black. So technically selecting this thing from manufacturer ID from product table where category is sneakers, color is black, list price over 70. It's gonna give us some manufacturer ID with the in function. This one is gonna give us the final outcome, which is 14 items. Okay. And the number 2. Oh, the one that we talked, that over 60, I said two different technically over 2 inside queries. Again, this one, the one that we talked already. Okay. So one more time, we just have 1 week to the exam. Next week is gonna finishing chapter 6. So without any doubt, do all the assignments chapter 6 before the exam. Otherwise, exam is gonna be a little tough. Okay. Let me stop recording.